good afternoon, good morning, good evening, everyone, and welcome to today's show on how additive manufacturing is making a difference at Siemens Energy. So today, our presenter is going to be Pontus Johannes, who will get more of an introduction in a couple of seconds. And I'm your host, Mick Goodwin. So I'm an application engineer working on the EMEA team, born, bred, and based out of Ireland. So fun fact about me, I was a Markforged customer before joining over 3 years ago, which doesn't sound that unique now, but at the time, we were actually the first Mark II customer in Ireland and one of the first in Europe. And yeah, it was a very different company 4 years ago, as you can imagine, in terms of size, but has a very similar, like the same design philosophy we've kept for the past 4 years, which is to create smart, robust, and simple solutions that empower manufacturers and engineers to fix the issues of their world, big and small. So at the time, the technology, yep, was pretty simple enough. It was pretty unique as well. It was a simple FFF style process that produced composite parts as strong as metals, and all enabled through a cloud-based system, which was really just like very innovative in the space. So really interesting. And from there, we've continued to innovate. And following the same design principles, we've built a complete digital manufacturing platform called the Digital Forged, with a broader range of materials, from simple plastics to complex metals, an optimized and secure cloud-based software, along with an entire new range of hardware. And this innovation only scales through our customers. So whatever we build, we just build the tools for our innovation, for our customers to provide the innovation. So one of the coolest parts of my job is seeing posts on social media, not to promote Markforged particularly, but just individuals, individual connections or second connections, just proudly sharing some of the parts they produced and some of the applications they worked on, or some of the complex problems they solved through our technology, with no intentions of promoting the technology. It's just a really interesting thing to see and see it grow over the past few years. So yeah, the technology was really interesting, and that's why we bought it at the time. What made me want to join was the practicality of it and how applicable the technology was at all stages of the product life cycle. So from design to making to maintaining, it was applicable throughout, which is what we're going to talk about today with Pontus. But first, some housekeeping and a quick note on today's format. So it is a presentation, and as most of you have probably been on a webinar before, there is a chat box there to ask questions. So we do want this to be interactive, and we do want you guys to have the ability to talk directly to Pontus. So we will be asking some questions live. So if you put in a question, I'm going to just review it, qualify it, and decide whether to ask it live. So please don't take offense if I choose not to ask that question live, because it may be addressed in following content that Pontus is going to talk about, or it may be better suited to the end of the presentation. So without any more interruption or talk about me, I'm going to introduce you guys to Pontus from Siemens Energy.
Pontus. Yeah, thanks, Mick. And I'm sure you're going to interrupt me, even though you said you won't. So yeah, Pontus Johansson out of Siemens Energy. And the intent of this webinar is I'm going to drill down from what Siemens Energy and what we do with additive, and how does our additive journey relate to Markforged, and using that technology and other technologies as well, and try to make that an interesting show. And also, of course, as Mick said, I'll be very happy to answer any questions around that. And for those who wonder, right, what is Siemens Energy? We are a separate company. Since 2 weeks ago, we got spun off from our mother company, Siemens, which I guess is perhaps a more familiar company to a lot of you, being that Siemens is a brand that you can actually see on white goods and around you in industry, right? There's a Siemens brand on a lot of stuff. Siemens Energy is not really that visible, but we are, as shown on the screen now, an energy value chain provider, meaning that we work with generation of power in power plants. We work with industrial applications and oil and gas power feed. We work with transmission and transformation of power. We also have a large renewable section of our company working with wind power. So if you see a wind plant somewhere, wind power plant, it's us or it's Vestas typically. There's a few big players on that market as well. And we also work a lot on new energy business, which is about sustainable energy solutions for the future, which is really what we have to look at as a company. So that is our main, say, R&D effort, is around how do we provide solutions to a future energy setup that is better suited for a sustainable energy solution for all of us, honestly. And okay, so how is this important to us? Well, the energy we generate in our equipment is what feeds hospitals. If you go and get a CT scan, yeah, that CT scan might be made out of Siemens as well, but the power needed to feed it is electricity, and that comes from our types of equipment. And it's heating, air conditioning, lighting in your houses. It all depends on a 100% availability and reliability of the components we make. So we might not be very visible in day-to-day life, but if our products are not working, it will be very, very visible to all of us. So it's in the background of everyday life for most of us. And me, within this company, Siemens Energy, I'm a senior key expert on additive manufacturing, and have a background in industrial engineering and operations management. I worked across a few different countries through the last 25 years in industry, and got into AM back in 2014 when I got the amazing challenge and task to design and build our first additive manufacturing workshop here in Finspång in Sweden for Siemens at the time. And that was amazing. It's of course still running. It's one of the backbones of our additive journey currently. And my role now is to see how do we industrialize this technology and make it work right in a larger context and with more components, more types of technologies, and to see how this technology is impacting our value chain and our manufacturing setup with all it entails. And hopefully I'll get into some of those details as we progress here. And just to show what are the type of components we make, then when I say we make energy solutions, one of our major products is what we see on the screen here. It's a gas turbine. It's basically a jet engine on ground, where instead of propulsing an airplane, we take that immense power and turn it into a rotational energy, which is then transformed into electricity. And again, looking at a jet engine, it's a very complex, high-tech product, and so are our gas turbines. And additive manufacturing for us give us a possibility to improve the combustion system, the turbine where you actually generate the power, the compression where you set up the air pressure to be combustible. All of these are highly complex geometries in very advanced materials, where we see additive technology as being a key driver to making these components better. And better for us means they will live longer, so be more sustainable. They could have higher efficiency, so they would provide a better value proposition to our customers. Or it's just a general life cycle improvement in how these products live their life cycle. And when we talk life cycle, it's not an Apple iPhone or other brand phone with a few years of life cycle. These are intended to work for 15, 25, up to 50 years, preferably without too much interruption in operation. Meaning basically that we have components the size of a fist weighing about 1 kilogram that each generate the same power as a Formula One engine at full throttle. And that little component has to continuously operate 24 hours per day for 4 years, continuously, without failure. So it is high-tech stuff we're working on, and where we are applying additive technologies to make these components better. That's almost it. And this then is, in this turbine, combustion of fuel, of course, is critical. And I think this is really, what we see on the screen is actually an example of where additive manufacturing is a key game changer for us. So in energy, conventionally, you can hear about, we as the human race, we burn coal, we burn oil, we burn natural gas. In my basement, I could burn wood I chop myself from my backyard. But basically, to generate energy that can be used as electricity, a lot of it is based off combustion. And what we are now capable of doing with additive technology is to create combustion systems that burn hydrogen, meaning there are solutions in place to have a carbon dioxide free emission solution in energy. So again, additive technology is not the only solution. It's of course to create hydrogen as a fuel. We need electrolysis, for example, or so you need solar energy or wind energy to create hydrogen. But having hydrogen means that we can store a carbon dioxide free fuel and use it to create electric energy when we actually need it. So this for us is one of these game changers. And this is one of the things that we're actually very proud of. So we have a company in Brazil who has procured a turbine setup from us that is at least initially set up to run on 60% hydrogen, meaning that you have a huge cut in carbon dioxide emissions, right? And this for us is, we think, a core in the future energy solution for the world. It's not something that's going to happen overnight, absolutely not. But that type of fuel changeover based off additive technologies, among other things, is to us a core future technology direction. And so this is one example of why is additive important to us. Well, this is really a leading star in that journey. To get to that, I mean, this is having been able to make that hydrogen combustion solution and getting the first component out there for customer use. I mean, it's not something that happened overnight. So in Siemens Energy, we started using selective laser melting as an additive technology back in 2006-07, where we did our first demonstrators and we got our first piece of equipment. And along this time axis, right, a lot of interesting things have happened. So in 2013, we put our first printed components in actual operation in these types of gas turbines. And going forward, we move on and we have 2016, we inaugurated our first, say, really industrial workshop that was built here in Finspång in Sweden. Moving on further, I mean, we've been working with additive technologies for a long time and on a broad range. So in 2017, Siemens decided to actually invest in Markforged, which is, I guess, one of the reasons I'm here today, Mick, is that happened. And having seen the potential of the company, right, and the technology, we figured this is something where we want to see more. And a year ago, we set up a print hub here in Finspång as well, based off not just the metal parts, because again, there's a difference, right? We, in our end components, we use metal. So back in 17, Markforged only did, I shouldn't say only did composites, but Markforged was focused on composites, which of course you can't put that in a gas turbine because it will melt or burn away very, very quickly. But still, there's this value, right, for us as a user of additive technologies to understand the range of applications and the range of technologies. So beyond the print hub we have that makes metal parts for gas turbines, we also have a print hub now with composite printers, because that is also very valuable to us, not to put in end-use engines, but for other reasons. And we'll get to that. And how do we see AM as a changer in our entire value chain and not just in what we're selling? And here someone wants me to sell stuff, sorry.
Quick question on that, is that okay?
Yeah, shoot, Mick.
Yeah, so like any of the attendees on the call, I'm sure there's one or two 3D printing geeks there, along with myself, and knows that Siemens Energy are, like, pound for pound, one of the main companies for really industrializing additive and really applying it to solve complex problems. So it was really interesting for me to see you guys like fully incorporate the composites technology, and I'm really interested to hear what was the decision behind that? Like, how did you come to that point where you saw composites and see it as a big part of your solutions offering?
And so, I mean, when you look at doing metal printing, there is, of course, still the challenge of cost. You can't ignore that it's an expensive technology to use. So it's great, right? The things you can do are amazing, but they come with a price tag. Turning to the Markforged type of printers and materials, there is a way to make components that are say, on a material quality level, not as, to that extreme level of the powder bed stuff we're making, but it's absolutely, as you said before, Mick, I think, it's possible to replace more basic materials like an aluminum fixture. You could replace that with an onyx reinforced fixture if the application is right, quickly, cost competitively, but it changes what is actually doable having this technology available. So it's a question of seeing how all these new production technologies that are evolving around the additive world, how do we apply them in an efficient manner and use them to our benefit? And in that perspective, I think, if I back the clock up to 17, Markforged showed some interesting results and had some neat technology to showcase, right? And big, maintaining in close touch with Markforged since then, it made sense to take that additional step. Is that an acceptable answer, Mick? Or?
That's perfect, thanks.
Okay, moving on a little bit then. I guess with the time we have, stay too long at each of these different little circles, even if I would love to discuss them. Let's see. So additive, what does it bring us, right? So I think you might be able to see my pointer. Conventionally, we are a conventional manufacturing company at heart, right? We do a lot of components, a lot of parts. There's a lead time for design and prototyping, and we are limited by the production technology available to us. With AM, what we see is at minimum two directions that things are changing for us. One is on our products, right? Our products are changing. And I showed you that hydrogen burner before, the combustion system for hydrogen. It just means that we can do something completely different on our products, and we can change, as it says here, right? Weight and materials. We could scan an existing part that we made and recreate old spare parts. We could change the performance of our components. So the look and performance of our parts will be different. So that's one side. So that's the CAD side of things, right? What can you design? The other is the manufacturing itself. What does additive mean in terms of the changes to our value chain? When you suddenly have a much different possibility around making castings, toolings, fixtures, the speed is different, the pace gets different. You can do very advanced components in very low volumes, for example, with additive technologies, which might be almost impossible if you look at doing a investment casting solution, right, where you just can't pay for that on a low volume part. So we see two different directions of how the technology is changing us. And those two together means we really have to continuously now rethink our business to understand how is additive changing our reality. And it's for us, this is not a future scenario that additive is changing our business, because here and now it's already happening, right? And it continues to happen. It's not an instant, but I would say currently the changes that are happening are extremely rapid, especially in such a, say, normally very conventional business as ours. The speed of change is very high as we see it with this technology. So additive does, yes, the first thing I think a lot of engineers think of is it changes our product and design capability. But for us, it's also about the supply chain and our value chain and what it will look like in the future. And looking at an example of that, how additive actually did change our value chain, our way to serve our customers is this. I'm not sure how well it shows because we printed this in a hurry and we didn't have time to take proper pictures of this. But what we see here is the inside of an X7 printer. It might be familiar to a lot of you guys online and gals. And these parts are here shown being assembled with a bolt through each of them, or a screw, actually, into a gearbox. So this gearbox is used to change the rotational speed of approximately 25 megawatts of power. And we had a customer in South America who needed to have that gearbox realigned. And this little black plastic tools, as they are, they were missing. They are originally a cast iron tool, so heavy chunks of metal that are used to align the shaft of this gearbox to get it up and running again. And we had an overhaul of this customer site happening in about a week's time. And these tools, which were customer owned, were missing. There were no tools. We had a similar set, but not the right set in our factories here, but we couldn't ship them because we needed them in our factory. And it's just a question, how do we then make this? So it ended up with us re-engineering a tool that we thought would work. And this onyx parts, the onyx parts we see here, are among the most expensive parts we've done, because there is, to make them substitutable to cast iron part, there's a silly amount of carbon fiber in these bodies. But on the other hand, it meant that we could re-engineer these parts in about a day's time to create the model for them. We printed these parts over the weekend. So I think we got this information on Thursday that we were in a very bad situation for an overhaul in South America. We could take the parts off on Monday morning and hand them over to our field service team, who would actually bring these tools with them to the customer on the flight on Tuesday afternoon from Europe to South America, and perform the overhaul on schedule. And again, at this, if we look, we tried to speed up. I know that the team who was going to do the overhaul, they got the information that these tools were missing on site like 1 or 2 days before we were given the task. And it's just, they tried to stress through the value chain to get this from the original supplier, because it's the gearbox manufacturer is not Siemens, it's an external company, and they are responsible for making these tools, but they had no tools on stock. So basically it was roughly 2 months lead time, and that was the rush order to make these tools again. So we were in a bit of a tricky situation, right? But with this technology, right, we could create a solution very quickly. It meant that we were able to perform according to customer expectation, and to help the customer out of a tricky situation, which they in a way knew they were responsible for, right? They were supposed to have these tools, but at the same time, they were relying on us to solve the problem for them. So no matter, it doesn't help to play a game blame here. The customer needed to have their energy generation equipment up and running, and we felt an obligation, of course, to try to help them as best we could. And again, using additive technology, that was feasible. Were these printed tools cheaper? I couldn't tell, to be honest. But was the value we generated for the customer high? Absolutely. Could we get paid for it? Unfortunately not in this case, but at the same time, a happy customer is a returning customer. So of course, this was the right thing to do. So again, an example how Markforged technology, right, was used by us to help our customers keep a country in South America electrified, more or less. So from my perspective, a really cool usage of technology. And Mick, you want to say something?
Yeah, absolutely. I think it's really powerful from a customer relationship point of view. But when you heard about this issue, could you walk us through the decision-making process of choosing Markforged over, machining stainless steel, or even you've got the MLS systems that could create a stainless steel part?
I think for us, machining these out of metal, right, would be tricky, because you need to, first of all, you need the CAD model, but then you also need the CAM model, because these are, the geometries are fairly advanced in a way with curvatures to make these tools work. So it's not just a straightforward chunk of metal. There's actually some advanced geometrical features on it, which meant that doing the CAD and then doing a CAM model to manufacture this on a CNC machine, for example, we wouldn't have had the time. So it was not an easy solution. Of course, there were options, right? Our field service guys and girls are typically very, very good at solving problems at site. Because again, as I said before, if the equipment is meant to run for 25 years, what you have 25 years into the future after you solve the part, it might look completely different, because even metal ages, changes shape. You replace parts with parts that might not look exactly the same. So, and that's the day-to-day life for our field service team, to figure out how to maintain the equipment in a good manner, even though it's not according to original spec anymore. So they would have figured out a way to do this. They know, because they have had the same issue before, but it takes them several days on site while the unit is down to do this alignment with, say, makeshift tooling. So it's possible to build a structure around the gearbox to align it, but it takes time. It means you have to go and buy stuff. You need to build stuff, weld stuff. It's not ideal from an EHS perspective. It takes time, and it's significantly more costly than getting a fully working tool with you to a customer site. So of course, we would have helped the customer. So it wasn't that everything would have been stopped for 8 weeks because we couldn't get the OEM tool, but being able to do this was for sure a much better solution than having our field service crew coming up with something on site.
Absolutely, and it avoids the whole issue of multiple processes, possibly multiple printers locally. Yeah, far simpler.
Yeah. Basically, the cost and chance of being away from home as well, right, for another 4 days just to try to do this. Whereas with these tools, it was a few hours worth of work instead of several days worth of work. Absolutely. Also, what we got as a feedback from those of us who care about that is making this part in a composite means they're a lot lighter than the original cast iron stuff, meaning that when you're on site, and this is actually the picture doesn't tell the full story, but it's a tricky operation where it's a hard to reach location, and it's a lot easier to stretch your arms in and fiddle with these parts when they're made out of a composite weighing a few hundred grams than when you have a cast iron piece weighing 6 or 7 kilograms a piece and trying to assemble that in a fairly sensitive area as well of the machine, because the gearbox is a sensitive piece of equipment. So from my perspective, a composite tool like this is a superior solution to the OEM version.
Good to hear.
Yeah, just my opinion on this. Okay, on time, I'm probably about to not fulfill this on target. Again then, just very briefly, right? I showed you the picture of the hydrogen burner. We used the same picture. Of course, it's not an identical part, but printing this burner, because we have a similar one today made conventionally, but just to show what additive does. When we make this conventionally here, basically we weld together 13 metal pieces through 18 different weld operations. We put a thermal barrier coating on top of it, and it has a 26-week lead time to make this part. When you substitute that with a printed version, it's one integrated metal part. So it's just one article number to keep track of, for example, in your ERP system. It's better from the perspective that it's better cooled. You don't need a thermal barrier coating, and it takes about 3 weeks to make this part. So there are changes to a value chain that goes beyond just the function, like here then, the capability to burn hydrogen. But that's not all. It also changes our value chain significantly. So anyone here who's into maintaining stock levels or doing production scheduling and planning would see the change in your operational behavior if you have the upper component versus the lower component on this slide. So that's a huge change in how you run your operations. And just to show what are we Siemens and Siemens Energy doing on AM? Well, yes, we think we are a strong user of additive technology, right? We do it for our new products. We use it for maintenance and repair and to figure out obsolete parts as shown. We do it, of course, a lot for prototyping and for tooling, right? So, and looking at the Markforged, we use it a lot on the maintenance side and on the tooling side and prototyping. We don't really use it for new products that go into the hot gas path because, again, the materials are not there yet. That said, seeing the Metal X develop is, of course, interesting to us. So that's one side of AM, but we are also, we think, a user of AM, right? So when it comes to this digital end-to-end chain, how do you set up a design tool? How do you monitor your printing processes? How do you set up a cloud-based solution in where? How do you create a manufacturing platform that works across, because we're a big company, we have different sites, different areas of working. So we need to connect all of this in a way through Teamcenter or some other solution. Of course, with Siemens, I've used Teamcenter in mine, where there are, of course, other brands providing same information sharing solutions. But understanding and using all of these software and automation tools in the additive environment is for us also a critical changer to how we apply additive technologies. Trying to keep times. Footprint, so where are we? What do we actually do with additive? I mean, I said we have a long history, we have different technologies, but where we are in the world then. So I'm up here, Scandinavia, Finspång, where we have more than 5,000 square meters of basically printing factory space with a fair amount of printers. What we see on this slide is EOS M290 printers, but there are other brands, of course, as well, of printers and sizes. So that's one of our major hubs. Another major hub for Siemens Energy is the one in Worcester in England, where we, shown on picture here, a new building where we're actually focusing very much on supporting external demand. So if there are any need of making advanced metal components for from powder bed, they are the place to go. When we look at Markforged hubs, that's Finspång. Yes, we also have a growing hub of Markforged printers in Orlando, in an innovation center in Orlando. I guess if someone tunes into Markforged webcasts next week, there will be a discussion with Cliff from our Orlando team as well, just telling a little bit of how we use additive there and what's happening also on that side of the Atlantic. And since additive is a core technology for us in the future, of course, we have development centers also in other areas. So Siemens Energy, we have strong operational centers in Montreal, Charlotte, and Berlin, where printing, of course, is available from an R&D perspective. But if someone wants something printed for them, it's in volume, or well, we'll do prototype as well. It's Worcester and Finspång where we can help.
We've got a question, Pontus, just on the pretty interesting for people that would be interested in engaging with you guys. It's more along the lines of like qualifying a component. So determining what components within the turbine and tools are ideal for additive, and probably to follow up from that, like which additive process, I would say.
So coming on, so I'm not sure I fully got your question, Nick.
Components within your turbine, how do you know which process, is suitable for additives?
So for us then, if you look, I mean, we started with SLM, and that for the reason that with the powder bed printing, basically we get material that's 100% dense. And when you put metal parts through the temperature ranges we do, if they're not fully dense, they have a very strong tendency to crack as they heat and cool over time. So for the gas turbine internal applications, full density is critical. Of course, if you know, for most metal applications in the world, that's not the case. So that's kind of the main driver. But at the same time, those who know who use it knows that using the powder bed technology is still expensive, right? You really need to have very expensive components to start with to be able to replace them with a powder bed solution. And not everything we do, of course, requires that type of material quality. So for us to understand the other alternatives around additive as they grow and are maturing, that's for us really important. So that's what, looking at the Markforged technologies, which are high quality, but not high quality for very hot applications. But again, we see, of course, a potential around using the Markforged technologies in other areas and other additive technologies as well, right? Because there are some really interesting stuff in development, I would say, around wire arc or electron beam stuff that, of course, we monitor and stay up to date on all of these technologies. Here and now, we primarily use powder bed and the Markforged extrusion stuff. But with Markforged, I would say it comes down to material very much. That you have a reliable, consistent material is for us critical. That we know what we get.
Yeah, good point. Good point on materials, and also like people think there's one job, there's one like tool for every job or one printer for every job, and that's not really the case. There's different tools for different jobs.
Yeah, absolutely, absolutely. Trying to move on and keep my times reasonably. Just Yeah, almost. So this just kind of some examples where we have, well, it's a generic slide we have, but showing some examples of what we do with the composites, right? So I showed you this unique tooling. What we also find is really useful is fixturing, because I said we start to print more and more stuff for our engine components, and with additive means that we can create amazing geometries. But the challenge with an amazing geometry is when you need to machine it, there's no way to clamp it, to grip it, to handle it, which means that we need very advanced fixturing solutions as well. And here I would say we have a great benefit with Markforged printers, where we can make a strong, solid fixture with onyx or reinforced onyx, for example. That serves a great purpose in terms of speeding up the post-processing of anything we print on the metal side. So this goes back to the changes in value chain. It's not about changing the product. This is about the value chain. How do we actually get an advanced metal printed geometry through the post-processing, through the value chain of, you know, how do you clamp it? How do you polish it? How do you do all the things you need to have an engine-ready component? Because to be honest, basically nothing that comes directly off the printer is end-use ready. There's always some type of post-processing, polishing, machining, heat treatment, something that needs to happen. So composite for us, advanced fixturing is very important. Rapid solutions, right? Whatever we want to. Here's just a number of plugs that has a hole through it. Again, something we needed at a phase in our production. And okay, how do we get these tubes into production quickly? Well, do we try to drill metal piping, or how do we do this? Well, no. The quick and easy and efficient solution is to print this. It looks like a basic component, right? But it has to be at a specific inner and outer diameter. Printing has advantages occasionally. And rapid prototyping. If we need to quickly do an assembly mock-up and we can't wait 9 months to have the metal part finalized, well, could we do the assembly mock-up with a printed onyx part? Yeah, we probably could. We have done. And this picture is blurred because I don't want to show you what's actually on that picture, to be honest. But yes, so composite is, for us, it serves a range of purposes, all good and all in this realm of it's changing our value chain setup. And I think, yeah, I'm trying to show this as well, because this is really what we're trying to do. We're trying to be outstanding in the field of additive manufacturing and have a unique selling proposition, whether it's for our own components or for helping other companies, which we realize we can do more and more. So we have the references in terms of getting parts that actually work and live in very advanced industrial operation. We have the capability around alloys. We have patents. We have solutions that are, say, at the efficiency frontier of what additive can do. We are quality certified, and we try to offer complete solutions, whether it's to our customers who need additive help or someone else, right? We have, we think, a great understanding that we're happy to share with others who are, as long as it's not a competitor coming to us, we'll be happy to discuss this. Because for us, that's a way of advancing our knowledge as well, right? Being challenged on what can be done with additive means that we get better at it. And we believe this is a technology that we have to master for the future, because it will only be more and more relevant to our survival. And now I'll try to be quiet for a few seconds, Mick.
Perfect. Thanks very much, Pontus. That was excellent. So now's the time, guys, to ask some questions if you have any. I've got one straight off the bat. I think it's fair to say, given the timeline that over the past decade, your main output has been metal parts, let's say. Mm-hmm. And it would be interesting to know how you see that evolving over the next 3 to 5 years versus composites, let's say.
So I mean, if I look at our turbine components, of course, that will still be metal parts, right? Of course, we're looking at possibilities on composites as well. I have to admit that, right? But it won't be on the hot end of the jet engine. So if you're not familiar with gas turbine lingo, if you look at it as a jet engine, at the cold front end where cold air comes in, yes, you can use composites. You look at GE aircraft engines and they have carbon fiber blades at the front of the aircraft. So of course, that's a composite. If we could print that in a clever manner, I'll be happy to do so. As you go further into the jet and it gets hotter, you can't use composites until you get to the fact that you can actually use certain composites as long as you don't put plastic in them. But that's, again, a different thing, I believe. At least now, with technology advancement, there might be, you know, ceramics, stuff like that come into printing, additive technology, but that the plastic type of parts will not be in our hot section for quite some time. But at cold end, yes, it's being explored to some extent, but it's still very early to say that it will happen. But it's, of course, we look at all these options.
Cool. Cheers. And like we actually have questions on the chat. So Afid Zirai has a question about in situ part analysis. So do you develop, this could be relatable to us as well, Markforged specifically. So the question is, do you develop any in situ part analysis to monitor the printing process? So melt pot monitoring, I think it's
so yes, I mean, this is the quality assurance of the metal printing side is critical to us. I know, you know, looking at the X7s, which we use, you have some in situ process monitoring, right? There are some existing solutions on the metal side as well, and on top of that, for us, with the hot parts we make, the quality assurance we need means that yes, we are looking into how to monitor that in an efficient manner. And some might have seen that there's been in the industry, we have something called the AM monitor, which we use, and which is actually, there's some availability online, I think, to look at what that can do. So that's one of these say quality assurance technologies we are working with to make sure we have a solid part at the end of the printing process.
Okay, perfect. Yeah, like
the easy answer would have been yes, right?
yeah. No, it's good to hear the description though, but on our end, just on the Markforged side, that's absolutely something we're working on as well. So we have a goal of combining your manufacturing and your quality control all in one process. So I'm not too sure how much I'm allowed to talk about right now, but we have talked about a piece of software called Blacksmith in the past. Specific to the X7 is enabling that laser that we use for bed leveling and using that to actually check the dimensional accuracy of your part. So your part comes off the build plate with a dimensional accuracy report as well. So something exciting to look forward to, and that will be on one of the next updates in Q4 for your X7 if you have one. If not, feel free to reach out. So let's see. So David Schulzman, how do you see the potential for additive manufacturing in the wind industry?
Yes, I do, right? I mean, if you look at wind industry, one thing, of course, is the blades. You have a large wind turbine, and yes, on those blades, I think there are on the finer details in terms of aerodynamics. I think there are some. It's not my area of specialty, but I think there are some ways of supporting the geometrical features on the blades themselves, where making those additively might be beneficial in terms of advanced features on what they look like, having to do with turbulence and other things that I'm not very good at. And then, of course, you have the electricity generator itself, right? So the generator in the tower, where I'm sure there is some potential for additive technologies to make parts in there. Again, how that looks like in live detail today, I'm not really sure, but it's absolutely something where, since you place a heavy object on a high pole up there, if you can lightweight that or improve it in one way or another, or reduce the need to service and maintain it by making a better part, I think that is of strong value, right? So I would expect there to be more and more additive going into the wind industry as well, even though it might not have been the first real, say, area of focus looking at the, say, the cost and challenges around additive technologies. But I would say that as the technology matures, it will be applied to some areas of the wind industry as well.
Absolutely. I'm just trying to wrap my head around the hardware end of things, the 3D printer needed to print a blade. It would
yeah,
be,
but I don't think I would see, well, who knows, right? You might be able to make a full blade as well eventually, if need be, because if, you know, from the cost side, maybe it will be just better to do it as you do it today. But when it comes to specific features on a blade, if you look at improving the efficiency of something that moves through wind like that, because again, that's in a way similar to the blades you have in a gas turbine. You need to work on your aerodynamics, and there are always features you could work on, I believe, to make your aerodynamics better. And printing allows for some pretty neat geometries.
Absolutely. Like if you can improve the effectiveness, it could easily justify the extra cost.
At least it might justify it, right? It's always this balancing act, but yes.
And then we've got Ulf Gleeman. Is there a challenge of meeting tolerances spec in AM compared to traditional manufacturing?
So this is a really cool question, right? Because the tolerance specs, if we look at our very conservative energy industry, it used to be about, you know, you would have a specific measurement points and you would need to make sure that your part would fit to those requirements. But as we're transitioning into a 3D model world where everything is based off models, you have a different way to meet the specifications. So the specifications are in a way changing. You don't just have the control checkpoints on your part, but you might have a surface reference, and you need to scan your printed part to generate that balance and check and overlay your actual results with the original model and see what are the deviations. So there's absolutely challenges to this, both to assuring that what you actually have in hand is what you designed originally, because it's with more and more advanced geometries, it gets harder and harder to actually do this validity check. It gets harder and harder to find the origo, the true zero. Where do you measure from and where do you measure to, when everything is an organically shaped part. So this is a challenge, absolutely. And for us, then, if you look at the value chain changes, well, you can't always just use a gauge measure to say if a part is okay. It's changing how you live your component through your value chain. So this is a challenge, yes, and a challenge we're working on.
Yeah, there's almost like new CMM sort of operations needed. These challenges that's presented by this new way of making things.
Yeah, because again, if you want to put a part in a CMM machine, you need to clamp it somehow. And then of course, how do you fix something that doesn't have a single flat surface on it? How do you make sure you align it properly to be measured right? So it's a lot of, you know, day-to-day challenges around getting these parts through a value chain.
Combining the processes sounds like a good solution. So, Hafid is back. Do you see any effects from the COVID-19 pandemic on AM in general? Work demand, projects, job offers, etc. I saw many companies doing 3D printed visors, but anything else?
I mean, we did so as well, right? We printed visors, we printed visor frames for healthcare, we printed it for our own field service staff, because some of them were going to countries where they needed specific protective equipment. And when you have a hard hat, it could be tricky to put on a visor as well. So it's about how do you get a visor that works with the hard hat outside. So we did designs for that as well, and actually printed it on Markforged.
Really?
We did Markforged printed fixtures to be able to put visors on hard hats. Yes, that happened over the summer. But other than that, on the COVID-19, of course, it changes. It provides challenges, right? Because lockdown or no lockdown is different in different countries and at different times. But looking at our day-to-day work situation in Siemens Energy, we're trying to stay away from the office as much as possible as a general rule, which of course mean AM work is tricky, because AM is a lot of it is in stuff that's happening in development. And how do you work on R&D and understand what you've done when you can't go and look at it, feel it? And so it's absolutely, the pandemic is a challenge in a lot of aspects for us. From work demand, yes, because again, looking at, from our specific case, looking at having the Markforged print up in place to help with say areas like making fixtures, making tools. Well, when we can't meet and look at the tools, look at the fixtures the way we used to, that slows down. I mean, applying new technology to people who are not used to it is really tricky when you can't be there and work face to face. So of course it's changing our speed of progress here, or it's changing the way we have to think about how do we continue to evolve when we can't do it the way we used to. So it's changing. Do I say that we have an easy fix for that change? No, it's hard work for us to figure out a good way forward.
Yeah, that's an interesting point, just not being able to kind of present and show people the different options. What does that conversation usually look like when someone comes to you with a part? Maybe they have aluminium in mind, and you say, hey, no, and they're not used to additive at all, and you say, no, let's try this science, what they might perceive as a science experiment almost.
Yeah, but I mean, that's the point. I guess that's always the challenge for someone working for Markforged. How do you convince a customer that, you know, this part made in reinforced onyx, yes, it can replace in a lot of instances a metal part. That is a tricky challenge. So it's that, yeah, make some prototype, show some parts, show some good examples of what you've done. And actually, if I scroll through another few slides here, I might actually have one example of exactly that, right? How do you, let's see if I can move along. This is actually that, right? It's an example I didn't show in the presentation, but you see the plastic rolls here, or the composite rolls, two of them. They are made in the X7s, and in this close-up, I'm not sure you can see it, but it's basically this roll with a handle on it. When you crank it, you have a strip of metal being dragged through here that is shaped by these two rolls into becoming a little clip, an assembly clip that you can weld onto our combustion system. So this is, I think it's some type of nickel-based superalloy strip. Right. But we can shape that and in a kind of a very basic stamping operation with tools printed off the X7. So reinforced X7 is hard and strong enough to actually shape the metal strip into little clips that we can use to weld on thermal elements on our combustion system.
That's really cool. That's like one of those great examples. I always talk about people's expectations when you show them the printer, the plastic composites. They come in with expectations down here, and you show them a few examples like this, and it's just, you always surpass their expectations with what is actually possible with it.
Yeah, I don't think this is kind of, it's something, you know, how would you have done this otherwise? Because we were buying these little clips from an external vendor, and we would have to buy them in huge bulks. And suddenly, you know, in the assembly operation, you would be out of this. Someone lost a number of pieces somewhere. You didn't keep full track of your inventory count of these little, because they're tiny pieces. Yeah. And when the assembly hall is stopped because you don't have tiny little silly clips, that's annoying. With this, you know, you need 10 more. You crank the wheel, you cut them off, you have 10 more. It takes you seconds instead of trying to order them and get them pulled from inventory. You get them yourself. Yeah. So it's again a change of value chain execution. Yeah. Because this is not about a product design. This is more in the value chain side of things. Let's change how we work.
Exactly. You just have the tool there to come up with these solutions. Like if you don't have Additive or Markforged, it can be very difficult to quickly iterate and get something like this going. It's not something that registers with you because you don't have the ability to make something quickly. So you just go through a traditional method. Yeah. So that's fantastic, Pontus. We're going to have to wrap up now. I know there's a couple of questions in the chat that we didn't get to, but we will follow up after the session just with answers to those questions. Just like to say thank you everyone for joining. I hope you guys found that really insightful and informative as I did. And yeah, Pontus, any closing remarks?
No, happy to have had the chance to present what we do. And I mean, we think a good company on Additive. So if someone wants to reach out to us, you know, we're reachable via email. I'll try to make this presentation available as a PDF to you, if there's a way to share it with the participants, that's fine. And kind of, you know, if someone wants to test to make something or discuss something, it's always possible to reach out to us. We'll be happy to figure out from Siemens Energy how we can support other companies with additive solutions.
Absolutely, and that's what a lot of people often need. It's not specifically the supplier support. It's actually industry experts who are have got experience in a broad range of technologies and not just one. So yes, Pontus, we'll be sharing your contact details. You have them on screen. We'll be sharing the PDF as well. So thanks everyone for joining, and Pontus, again, thank you very much. Really appreciate it.
Thanks, Mick. My pleasure.
Okay.